Hi, Kat here for Lightwave Digital. In today's video, we're going to be doing another conversion from Lightwave 2015 to Lightwave 2024 and working with the physically based rendering engine and texturing, surfacing, and lighting system to pull this asset from 2008 and a show called Lost Treasure of the Grand Canyon. This is a Quetzalcoatl, which was created as the monster in the show for Sci-Fi Channel and was done by Front Street Pictures out of Vancouver. Now, we didn't have a lot of time to design and put this character together, and he's got some issues with him, although most of them I dealt with in comp as best I could, because we were on an extremely tight schedule with very little money after a certain actress, who's now dead, took all of the budget away from us. So let's get this thing from 2020 or 2015 over to 2024. But you can see these, fully rigged. He's got some transparent wings on him. This was the part that I was mostly unsatisfied with. And we'll get him into Lightwave 2024 and ready him for a new life as a character that can appear in a future movie. All right, so let's get that done. Before jumping over to Lightwave 2024 to redo this asset for physically based rendering, let's take a very quick gander at what's going on for the surfaces. Here we have our Quetzalcoatl body. This was a nodal surface setup, not using anything too sophisticated, but this was a ZBrush created asset. So we had some normal maps, we had a bump map, color map, and a specular map with a displacement map as well that was recycled into various layers. We also have a translucency map or transparent map, which was specifically set up to control the edges of the wings. So you can see that map present down here. That's what that map is for. We also have a glossy map or setup, which I don't think we're going to use in the new asset. We also had reflection, which was being also controlled by that transmap. And then some noise for bump, just give it a little bit of flavor here and there. But again, I don't think that's going to be necessary because ultimately this bump set here is more or less being overridden by this texture. When we convert it over to Lightwave 2024, we're going to effectively rebuild this using a principled BSDF shading material, and we'll go from there. Let's take a look at some of the rendering here for this asset. This was rendered without ray trace transparency on it originally. It didn't seem necessary, and it was time consuming to go through those wings. So we turned that off and we just let it live as was in comp. In hindsight, though, I would have liked to have gone back and done a fully proper shaded material system for this. But as again, I said, we didn't have a lot of time to get this guy ready and get him into shots and start pumping things out because we had to produce trailers for Sci-Fi Channel before the film was even edited and complete so that they could start promoting it and everything else. We also had this puppy cached via Monte Carlo. This was not necessarily a great situation because when you're working with characters in the old system and you want to just brute force something, you would have various shifting shadows, all kinds of artifacts from the radiosity cache or the radiosity solution itself going across the network, causing issues because each machine would be slightly different with the final cache calculation. That's been resolved in later versions. This was done in Lightwave 9.6, by the way, so very, very early asset to be working with that with cached radiosity. Let's take a look at the camera. This was the original settings, 16 and 32, plus we had photo motion blur on it, of course, because we decided to do that in camera because it looked a heck of a lot better working with the red footage that we were working with in the shoot. So just a couple of basic lights in here. We've got a backlight, which isn't really a backlight anymore. I've turned it around. It is just an area light. We're going to need to redo that. And then we've got two balances in here. Plus, we also have in the backdrop a gradient backdrop, and it's being canceled out by the used background color. So this asset wasn't really intended to be lit by directional lights or even area lights very much. In the end, what I did is I actually used a Dennis Pontonier Rad Faker light plus a couple of smaller lights and took the background plates from the show where he would appear and wrapped them spherically for the Radiosity Faker or the DP Dome light to project, and it worked really well. So we didn't really need to do too much. He was supposed to be like a hidden dark character that would be in the caverns, and there were a couple of shots I did for it where they mistaken the actual puppet for the CG character, and they went, "Wow, okay, that looks great, great on the CG, puppet guy or the guy that made the actual practical puppet." No, it was CG, and when they saw the original, they freaked out and went, "Oh my God, thank God we didn't spend more money on making a full-blown puppet." So, at any rate, not much scary in here. This was originally rigged as a character for somebody that specifically worked with these types of rigs, and if you recognize them, you would probably recognize them as Timothy Albies, the character animator of Lightwave Legend, who has since retired from the industry. But this is a very interesting rig. It makes use of very old school techniques with a little bit of more advanced functions and features, including cloth effects and soft effects on the wings. Now, I'm not going to really worry about that in here, but the calculations for that are actually quick to do on a modern computer. And they do add a little bit of flavor just to the thin skin that's on the wings here. So really did help bring him to life, gave him a little bit more jazz, so to speak. And although it was a little bit more time consuming to do a calculation on that and then save it out, it actually worked out really well for us because it gave us a little bit more secondary or tertiary animation on top of his primary animation just to sell him in the shots. So now that we've got that covered, let's go and open up Lightwave 2024.1 in this case, and we will quit Lightwave 2015. Bye-bye. And we'll wait for Lightwave to finish scanning the plugins, and we'll go and load this guy up. I've already packaged him from Lightwave 2015 to make a scene ready for Lightwave 2024. So let's go and grab the 2015 version. And as we've discovered in previous videos where I've been covering this topic, loading an older scene version will give you this warning. This scene is from an older version of Lightwave. Loading and converting this scene will probably lose information, and these scene assets will not be compatible with older versions of Lightwave once you save it. Do you want to save a copy of this? I'm like, no, because I've already got one. All right, so no need for F prime because we didn't have F prime carry with us into the future, unfortunately, but we did use F prime for preview back then. So I'm going to hit no to that. And this guy will come in pretty much ready to go for me to start playing with textures. But you can see he's got a very strange transparency issue going on here. This is due to the OpenGL settings that I'm working with. So if we go over to the current scene, there's the viewport. We need to go and change our display, I believe, on our CPU or GPU. We've got all these additional channels in here that Lightwave is being told to pay attention to, but unfortunately these maps are inverted. When they came out of ZBrush, they were not done with the proper conversion, so I just flipped them in the nodal surfacing editor, but for Lightwave's OpenGL system, it's picking it up and going, well, you should really have it the other way, and that's why our guy is inverted. So let's go take a look at the VPR results for this. And first thing we're going to note is that because the light system has changed, the original area lights and other things are really hot. And we've got some pretty interesting issues here with him having excessive bump mapping that needs to be turned down. And just in general, he's really overexposed. We need to address this in a couple of different ways. Going back to the color space tab on the current scene, we need to convert him using sRG preset. That'll be the first step, and boom, we kind of get him back to like a regular-ish color, and he's not so blown out anymore, although his lights are still very hot. So let's take a look at the first light. There's the delete neat balance. We're not going to really worry about that one right now. Here's the area backlight. Go into edit nodes. You'll notice that you've got a light fall off property that's driving the illumination color. Um, I find that I should really just disconnect this and work with the regular inverse distance. But once you do that, you really need to make sure that that's disconnected so that you can dial this stuff in properly. And then the values will again start to make sense. I'm not going to use this particular light type for this. I'm going to go to distant, and we'll just give ourselves a little bit of shadow angle. Get like 5. That'll be good for now. And I want one of these, we'll call this the key light, first of all. And we'll go and take this other light in the background side. Let's just disable VPR for a second. Let's go back to perspective view. Let's take a look at this light here and see what's going on. Okay, so this was basically our key light. That's the one we want to keep. And then we have a couple of area lights that were bounces. I don't want that light to be there, so I'm going to just delete its keyframe. And we will go and delete the other light that's underneath of it that was just for specularity boost. And we'll go and turn this into a spotlight because we're going to need this to check something later. And we'll call this backlight spot. Okay, and we'll need to turn that inverse distance on, make sure that we've got rid of this fall off control in the node editor. Okay, we'll turn the diffuse spec and diffuse effect diffuse and effect specular back on, and we'll need some effect volumetrics in a second. We're going to increase the size of this spot to 250 millimeters, so it's a little bit larger, so it looks like it's an actual spotlight. And we're going to go around to the perspective here and just see where it's parked. So we're going to reset its location, and I'm going to just bring it up here and park it kind of behind him for the moment. We'll go back to the camera view. There's the wolf cam. All right, then we've got VPR. And we need to go over to the render tab, hit render properties for Control P, bring that window in. And we'll go over to this tab first and start unchecking a couple of things. First things first, let's turn MIP mapping off. Let's enable the D-spike, which will help eventually turn down some of these fireflies a little bit. Global illumination. I'm not really going to need this anymore. We can do that with an environment light. For volumetrics, yes, we're going to need this, and we're going to turn volumetric scattering on. Okay, and we need to make sure, first of all, that the key light, because it is a distant light, doesn't have the effect volumetrics on. We're just going to need the one for the backlight. So there's a backlight spot, and we can reposition this. Let's go and take a look through the light view. Turn VPR off because you're looking through volumetric effect. And T for transforming this light. We're just going to put it behind him and shine it through from the above. And this is going to help me when I go to texture his wings again, just so I can see what kind of effect the translucency will have once I get to that part. All right, so let's see what we've got here. Boom. Okay. Let's take a look at buffers. We don't really need anything just yet. Probably won't get into the buffer stuff in this particular video. I am going to turn the use preference path off for the output. If I decide to do some test renders in comp, I like to do that immediately because it's one of the things that I do not like about the new output system is this use preference path. This should be off by default, in my opinion, but that's just me. Let's go and take a look at his surfaces now. So one last thing before we do that, I almost forgot. Let's go to scene, image processing. Let's go to the backdrop. We're going to go and add an environment. go and add a gradient. Pardon me, gradient. And we'll go pitch. We'll do something kind of bluish, but nothing over the top. And maybe something a little bit darker at the bottom. Okay. And let's see what we get here. VPR just for the background, which won't do anything until we actually place an environment light in here. So we need to create an environment lights. Okay. Environment light. Let's shorten the length of this. Okay. And by default, this is going to come up with also its volumetrics enabled. We need to turn that off, and we need to turn off time dependent or use global. In this particular case, if you turn off use global, you're going to get the background in there, which is picking up this gradient. Let's go to the image processing tab. Go to compositing, and you'll see it's using the gradient background color. All right, now to cancel it out, we'll leave it canceled, and we're going to turn this light down to like 10%. All right, so now we've got something that, kind of is back to where we were, but we need to fix his wings because his transparency and the material isn't working anymore. So let's get that started. For now, though, just to speed things up, I'm just going to go over to the volumetrics tab, and I'm going to turn off enable volumetrics for the moment until we get a couple of other things addressed. Let's go and shift click on his main body surface. Thankfully, he doesn't have a lot of surfaces. Most of it is really his body. And we can notice in here right off the bat that we've got some textures that are still in the standard mode shader, which is what we're looking at for the most part right now. So we're going to right click this, and we're going to convert this to standard nodes. And we're going to go and edit that graph. And we're going to see that this has kind of made a little bit of a mess of things, but that's okay. We are going to strip this down to something that makes a lot of sense. Okay, so there's the original standard material. And then we've got the image maps that are applied into there with whatever additional textures were present. So effectively, I can, for the most part, largely get rid of a lot of these things here. But we're going to need a couple of these things just off on their own to make sense of. So for now, what I'm going to do is I'm just going to disconnect stuff because we're going to recycle these maps. And I'm only really going to use the color for this so that he has a material that's plugged into OpenGL, and we can turn off the bump and displays. And then I can effectively turn off all of these other values. I'm not going to get rid of them completely because I can use them for reference later. Okay. So right now he doesn't have a surface material plugged into him. It's only for OpenGL. So if we go back to OpenGL, we'll see that his transparency problem has kind of been resolved. He's no longer looking like a ghost, although this doesn't look quite right. He's kind of got some issues, but we'll get to that in a second. And it largely deals with these settings here. Ideally, this should be off, that should be off, that should be off, that should be off. Just to get him, back to some semblance of looking like a, consistently existing monster in reality. He's not a floating apparition or something of that nature. But now that I've got something that works for me in OpenGL and know what's going on, we can now start to replug things in and then build out a material shader that's more suitable for this type of asset. So let's reduce the amount of stuff that's on our screen for the moment and start working with this. Now I can go directly from the original bump map that was being used, which is this texture here. We use it as a displace. And then of course we also had this over here, which is bump. So I think what we're going to do is we're going to use one as a bump height and one as a displacement. And we'll of course also have a normal map. So let's just go with normal map first. So we'll plug that directly in there. That solves a lot of problems for us right off the bat with how he looks. And you can see that change right there in OpenGL. Okay, let's make sure that we're not using maps on this. This is not a image type that we want to ever use maps on. And let's go and make sure that we've got all of these other maps turned off for mapping, because we don't really need this in 2024 right now. Okay, so we'll just shift click them all, make sure you don't miss anything, and disable that. All right, so now we've got OpenGL covered. We've got the normal map covered. We're going to need these safeties. And we also have this bump map over here, which was a combination of another set of procedural textures. We might take advantage of that in a bit. So I don't want to destroy anything that I've got here, but I'm going to just set it off to the side for the moment. So we can start from up here. So we've got our base specular map. I'm going to take a copy of, our actual image node, because we're going to need him for color. And then we're going to go and get ourselves the principal BSDF material. Okay, so first things first, let's plug in color. That's the first challenge. We can now enable VPR. We're not going to get much except for what has existed without any material changes until we plug this puppy in to our surface. So there's a material, and then we get him more or less in a state that he exists in OpenGL. He's just got a color map on him, and whatever other settings are currently at are going to be picked up by VPR, and away we go. So now we can start to make use of these various inputs. The first thing, though, that I want to take care of is this translucency and transparency. So the transparency was made up of a series of texture maps. Now, I'm not going to necessarily need all of them, but we're going to use them in a particular fashion so that we can get a nice translucent subsurface scattered set of wings. So let's start with transparency first. We can use the scalar out of that. We're going to plug it directly into transparency. And we're going to notice that we've got some transparency on those wings now. Now that's all fine and dandy, but we don't want these edges to show through. So how do we get rid of that? Well, we're going to take a recycling of this in another channel, and we're going to plug it into clip. So what I'm looking for is just this particular layer, which is that speck edges. If you remember me opening this up in 2015, we're going to use that as a clip map. And maybe we won't take the Photoshop darken. That's probably need to be turned off and hit normal. There we go. So that fixes those edges, but he's not looking, quite what we want with a nice translucent and, somewhat transparent wing set. Like it almost looks like I've got the wrong inversion. So we need to deal with that. As I said, as we started out, there are going to be times where I'm going to need to just not try to use every single map. Sometimes that's not necessary. So let's take a look at what we've got here for transparency. I've got all these different maps here. I probably don't need any more than the original one as it was intended. Okay, so we're going to take that and make sure it's plugged into transparency. That seems to more or less be effective. We also invert that layer. That's not going to help us. Nope. Let's go alpha. Is that going to help us? Nope. But what is that base transparency set to? It's 0.3. Well, I think we need to crank that up. 0.7. Maybe even a little bit higher in a moment. Okay, so now that we've got that, we're going to double click on the actual surface and I'm going to hit thin. This will actually cause the winds to be evaluated as a thin material. And then we're going to start to crank things up for translucency. So let's go translucency 85% or 80%. Then we can take something like the other translucent or textures that we had and start plugging those in. Now I think we need to invert that, turn the inversion off, and just plug that in. So we're going to go and take the scalar value and plug that into translucency. Okay, and let's make sure we've got the right transparency here. Let's go normal. That'll help a little bit. Okay. So now what we've got when we open up his wings here is something that's treating his wings with a little bit more consideration to that light that's behind him, and it looks like he's got some flesh or some tissue that's there. Now, don't mind these low resolution textures here. It's just how it was. Um, Not a lot that I could do about that at this point, unless I want to go back and clean up some of those textures or run them through some form of AI up-res tool like Topaz. But we're getting somewhere here. Okay, so that kind of handles the skin mesh. You could probably add a little bit more life to that by adding in some additional map controls here. But I think for now, this is probably going to be good. The transparency is effectively the way I want it. The translucency, we could probably change this up a little bit with the additional controls of additional maps. So there's, for example, with the trans 2 map, let's go and set that also to alpha. Gives him some additional density to his wings. Let's take a look at it when it goes to additive. Let me invert it. Now that's affecting his body. So I think we're kind of good there. All right, so yeah, that feels a little bit better. All right, let's deal with some of his actual skin surface. We know that he needs to be a little less glossy right off the bat. And right now we just have the default. When you add a principal BSDF material type, these are going to be defaults. Roughness of 10, specular of 50. So let's get that specular under control. We've got incidence angle, FBM that came across, another FBM, and then the specular map that turns it off effectively in those areas because we don't want anything in there. Although we have a clip map, you never know what's going to happen with some of these surface settings for the first time until you see what the reaction is going to be. So let's take the specular and plug it into specular, and we should see kind of a reduction of what's going on. But his roughness is still just the default of 10. So let's take the reflection control, or pardon me, let's take glossiness and use this as an input for roughness. So we'll take the scalar value of that, go into roughness. He's got a different skin texture now. He's not so super glossy. He's still got some life to him, but he doesn't look like he's covered in slime. Because that was one of the notes that we got back from network. He's like, he looks really slimy. Well, he's supposed to be like, creepy. But they're in a desert. Okay. I guess that was how they wanted it, so that's what we did. Okay, so that pretty much handles that sort of thing. But let's take a look at what we can do with subsurface scattering here for a second. We have an additional map here that I can use. It's down here, and I'm going to plug this into subsurface scattering. I'm going to start to play around with the amount of subsurface scattering he's got. So let's go 50%. And we also know that we've got a map here that we could probably use as a mask for that. So let's take a luminance and plug it into, let's see. Let's see if we can control the transmission distance. And then, of course, the color for this map. So you'll have to deal with that bump map in a second. Let's go a little bit more, 90%. So you also want a little bit of color or clear coat gloss control. We might be able to take advantage of that. Let's put that into transmittance instead, and we'll take translucency. I'm going to invert this. Right. And we're going to take that, and we're going to control clear coat gloss, clear coat, and then we can give him a gloss value, 50%. Okay. Starting to look pretty spiffy on the wings. His body's looking a little bit better. His bump is a little bit too displaced. We're only working with the normal map right now. And there is a bump map specifically for this bump map arrangement. This is probably going to be way too much. So let's just leave it for now and plug it directly into the surface. Okay, we'll see what we get here. This was designed initially to help give him a little bit more tooth and breakup, but you can see that it's having some issues with where his UV maps actually meet. Largely because the normal map, the way it's been produced, it was produced up against white. Might have to invert that to solve that problem. This makes them look a little bit more fleshy. This did come out of ZBrush and his amplitude. Let's just crank it all the way up to 100% and see what it does. See how we've got all kinds of weird issues there if we don't have the proper inversion. It looks really questionable at a certain point. So let's go 25%. Feels better. Maybe 40. It's not as much as he was before. That's what I'm looking for. That feels better. Okay. So next little bit here. We have this transmittant distance. I think we can probably also recycle that into a control for the clear coat gloss. All right. And that pretty much handles his texture. Now, there is a slot for surface displacement here. So again, oops, let's not do that. Undo that. There we go. So luminance for that will go into displacement. And we will go and check him. Objects. Make sure the main object is selected. Hit P for properties. Pull up his object properties. Let's get rid of his surface editors for now. And you'll notice that we've got this lovely deformation stack, which I covered in another previous video, that helps us arrange where displacement takes place in order. So we can actually enable a deformation on him based off of the surface displacement and pop a value in here of like 10 millimeters. And that'll give him a little bit of a return for that veiny look. Okay. And of course, these can be rearranged depending on which way you want to go. If we don't need the soft effects applied, we can turn it off just to speed up things if we want to move him around and not worry about having to calculate it and get the proper look. If we're just doing some base animation. There are some morphs on this guy, so we can access those through the deformation stack, rearrange them, all kinds of fun stuff. and he's pretty much converted. Now, this is a fast conversion, just so you can get an idea of where everything is. What I'm going to do here is I'm going to actually replace his object with the one that I did, and we'll take a look at what settings I had. So let's take a look at him from the 2024 version that I did. And you'll see that just because of the lighting change on this, he's looking kind of rotten. But let's take a look at why. Shift click on a surface. Oh, we have two versions of him in there, I think. Oh, he's good. Okay, so let's flip back. Damn. Let's go load the scene. All right, a little bit better. So very similar type of texture arrangement. Recycling those maps where useful and plausible. There's a displacement, there's the bump, there's the normal, there's the other bump. Probably don't need this one plugged in. And now you get a really good idea of what his wings will do with the transparency map that it was. This layer and this layer. Plugged in, and then we had a translucency. There we go. Those two controlling the translucency. Same concept though with the fin on his wings. And we can even crank this up, I think 50. It's not looking too bad. Similar concept with using the glossiness specular or specular as roughness control, but with some of the maps inverted. And that way he doesn't look super greasy, but he's still got like some specular highlights on him. And right now he's not doing much in terms of reflecting anything with the background. If we go and take in a HDRI of sorts, let's use the blur loft and pop that into our environment light. Turn that off. Let's replace it with the environment light. It's like he should be in there. He's pretty much ready to go. Depending on what your lighting situation is, but he's really not that hard to convert. Yes, there are other materials in here that I would have to take care of, but the idea behind this is that using the original maps sparingly, I could probably strip this down to bare minimums. The real important ones were the translucency and transparency maps for his wings, and then bump and normal map for his kind of skin. really don't need a lot more than that. So when converting something over, you may have had large amounts of um, textures that were used to create something that looked photorealistic uh, from another program, such as ZBrush or 3D Coat. These days, those programs spit out based on one of the several theories for, conductor, metallic, um, principal BSDF, skin shading, whatever it might be. Those types of material theories as image map controls, which are just masks effectively, with the exception of color, can very easily and directly plug into Lightwave in these materials. So you probably take that route instead. But if you want to remix and map those colors or maps from previous asset, you certainly can. Just you may not need everything that you pumped into there to get the result that you're looking for. Let's take this copy, put that over there, just to make sure we're not looking at anything else that shouldn't be. Yeah, there we go. Okay, now let's say you want to make him look more filmic. All right, well, we've got a couple of options here. One of the things that we did not have in previous versions of Lightwave was with VPR a tone mapping system. And this was introduced in 2018, and it is a tone mapping system that allows you to work effectively in real time based off of several different formulas for color. So you've got linear, Reinhard, filmic, and then ACES filmic. So if you want to mess around with this in real time and add some flavor to his color, you most certainly can. Like when I imported this originally, when we loaded it, I had the tone map turned on. So this is with the tone map with filmic. We've got a cutoff control. Crank up your exposure. And really change the look of him while doing so as a post-production filter. Keep in mind, I've also got this volumetric light on in the background. So if we turn that off, you're going to get a different look in the front. So let's turn that off for a second. And just to speed things up as well, let's go camera, turn off the motion blur for a moment, just so we can see how well he cleans up. So he's looking a bit more natural. Or as he is, loaded into the scene with that HDRI. Now there are a few other pixel filter handlers in here. The nodal pixel filter is one that you can completely create based off of nodes. This is something that you can experiment with on your own, but any kind of distortion map or something that you might want to place in here can be achieved nodally through this method and this interface. And of course, it will work as fast as VPR can keep up with it because it is a real-time section, so to speak. These are real-time sections. But this one with the image filter handler, this is not. Any of these are not going to produce a result in VPR. You have to F9 or F10 it or render it over Lightwave ScreamNet or the NRC to see those results. This section, however, is real time because it also includes things like fiber filter, which we would need for visualizing hair and strands. Turn off that backdrop. Back over to my light here. And also remember, if you have an HDRI in here, you want to start making modifications to its brightness or color, you most certainly can. If you're finding that you have fireflies on a particular surface or something like that, and it comes in only when you have the environment light enabled, or background that's using the environment light for that backdrop, and you're getting fireflies in there, go into this panel for under edit and first things first, turn the Gaussian filter on, and then make sure either you have under the render tab the enable despike, and then if that still doesn't work, take a look at the surface under the shading material and look for the reflection and refraction overrides if you're getting noisy little sparkles inside of your surface, if it's transparent or it's got refractive properties to it, such as dielectric or skin shader or surface that has refraction. Start dialing these samples up before you go and start cranking these samples up, because really you don't need to dial this up because this is a global control. These ones you can go right down to the surface to clean any of those issues out. And you can see here, just after about half a minute, we don't really see anything in here that's bothering me in terms of those sparkles. There may be a couple in here that are actually supposed to be there because they're driven by texture. And by driven by texture, I mean physically in the material that is being caused by one of these texture inputs. If you get into a situation where you can't get rid of a sparkly Firefly artifact, it's almost always going to come from one of these maps being overdriven or being used in an improper way. So that's why I suggest pulling everything out that you don't absolutely need first, and then building it back up until you encounter that problem or you achieve your results without hitting that problem, because you're now able to import and input data in a way that makes sense in a physically based renderer, because we now have that capability. So if you're working with ZBrush, 3D Coat, Mudbox, or any other paint programs, even including Mari, that allow you to spit out these proper surfacing material formats or formulas or theories, including Substance Designer, Substance Painter, those maps specifically will have values and purpose for going into these inputs on various materials. So we use principal BSDF here. We could likely have used, say, the skin shader. Very similar inputs, although a little bit more in depth specifically for skin. But he is a lizard. He's all skin. But I don't think his maps would have been suitable for this to begin with. However, you do your dinosaur or your humans like that. His wings, if they were a separate material, or if I wanted to use a material switch or a material mixer, I could do his wings with the skin material, and then the rest of him with the principal BSDF, and that would be actually quite doable, I think, because I've got the maps to control that. So yeah, I think that it would be quite doable. So recycle the maps when necessary, but don't try to use all of them all at once. And if you can get away from having to mix materials with standard material emulation, your renders will go that much faster. Because again, the standard material is an emulation of the old render engine. So if you're working with a physically based material in your scene and then you step it down to the emulator, all of the other materials have to slow down to accommodate that standard emulation shader. And you can see that this actually cleans up really nicely. He's got his specular highlights where he needs them. Yeah, he's a Quetzalcoatl. All right, thank you for watching. We'll see you again in another video.